Hi, everybody. Welcome. Um, good morning, good afternoon, good evening, wherever you are. And welcome to session one of our brand new Data Science Workflows in JavaScript workshop series. This is session one of this series. And just as a reminder, we have two more coming up over the next 2 weeks. But we are really excited to lead this series that really introduces folks to different methods for accessing data, tidying data, doing some wrangling, doing some exploratory data viz and analysis, doing some modeling, and then putting together some final visualizations. And along the way, we're going to be using not only JavaScript, but we're also going to be using and learning a lot of cool features, some of them very recent features in Observable to get you all up and running in Observable Notebooks so that you can be independent users working happily in JavaScript to do your data science work. So I have a couple of slides. Oh, it's awesome to see all of these places that people are all calling in from. Hello. Hi, everybody. The first thing that I want to do is go through just a few slides. We're going to very quickly get into like all hands-on practice in these workshops, but I have a few slides to introduce this session and our team. So first of all, most importantly, perhaps, is the people who are going to be helping you along the way. So I am Allison Horst. I am a data scientist advocate here at Observable. We are also joined by Robert Casara, who is a data viz developer here at Observable, and Wayne Sutton, our community and events manager at Observable. So if you have questions throughout the day, you are welcome to put them right in the chat where you can see people posting where they're calling in from. Hi, everybody. So you can post them right in the chat, or you can join our community Slack and post your questions there. And if you have questions that don't get answered during the session today, then I'll be looking through the questions afterwards. I'll be looking at the community Slack afterwards, and we'll make sure to follow up with you there. Okay, so please feel free, post your questions. Seeing some love for Robert's recent advanced data visualization course. I love that one too. All right, so our team is here to help. Please feel free to post your questions. We'll try to get through all of them today, but we'll follow up if we can. Okay. So a few logistics before we jump in is, as a reminder, again, this is the first of 3 hands-on workshop sessions. They're each 2 hours. The first one is today, Tuesday the 11th. Some people might already be on a different day. But anyway, in Pacific time, Tuesday the 11th, 9 a.m. And then we'll have one each week over this course of 3 weeks. So every Tuesday, next week and the following, 9 a.m. Pacific time. There's a certificate available at the end of the workshop, and we'll be posting the task immediately after session 3 to get the certificate for our data science workflows in JavaScript series. The requirements are to attend and participate in these 3 workshops, and then complete that task, and then you'll submit it and we'll review it, and then you will get your certificate for completing and working through and gaining the skills that we hope people earn from this series. So a couple of things, just in case folks haven't done this yet, that you'll need to do to be able to follow along. The biggest one is you need to have an Observable account. So if you don't have an account already, make sure that you go to observablehq.com. We can share the link to sign up so that you can create a free account, because you're going to need that in order to follow along today and save your work. So make sure that you have your Observable account ready. We'll be sharing a notebook in just a little bit that you're actually going to fork to make your own copy so that then you can start working in it. Again, I already mentioned the questions. Post those in chat here or in the community Slack channel. And again, like, I'm going to try to go at a pace that's manageable for folks even who are relatively new to JavaScript and to Observable. But you can rest assured that all of these sessions are being recorded. And we're also going to share my complete instructor key, which has kind of like more detailed notes. It has all of the code that I'm going to be writing today. So you'll have access to all of that material in case you get stuck at any point or want to go back and revisit anything that we've done in any of the sessions. So I think that covers the logistics. So what we're doing in these workshops is we're going to be exploring several of the many different options that exist for working with data in JavaScript and in Observable. And if you've been working in data science for a while, this might look familiar, this kind of adaptation of the R for data science schematic of the data science workflow, which goes all the way from accessing data, importing it, to tidying and transforming, doing visualization, whether that's exploratory or final visualizations, doing some modeling to answer questions that we care about, and then perhaps iterating on this, and then finally communicating these results through visualizations, text, tables, and to other people who are interested in or impacted by or need to provide feedback on the work that we've been doing. So shown here under each of these different kind of bins are some of the options that we're going to be working with. And the idea is that on each day of the workshop, we're going to kind of take a different path through this schematic so that by the end of these 3 workshops, you actually will have a huge number of options of tools and features that you can piece together to get from A to Z in your data science workflow. So that's what we're going to be doing in each session. And today we're going to be doing kind of a gentle introduction, expecting and hoping that for some folks, this is not only like an introduction to data science workflows, but that for some people, this might be your first time working in Observable. For some folks, this might be your first time working in JavaScript. So this will be kind of our mellow intro. And then in the next sessions, we'll be diving right into JavaScript code and some models more quickly. So in session 1 today, we have a whole bunch of learning objectives. We got a lot to do, but I think 2 hours is going to go by really quickly. We're going to learn how to attach a file in an observable notebook. We'll be using a CSV file today, a comma-separated value file. So we'll learn how you can get that into a notebook and then load it in so you can start very quickly exploring it. We're going to be exploring it in the data table cell to start, and we'll see that that's an interactive place where we can also do some data wrangling. We're going to use a new feature, the chart cell, to get us started with some charts in Observable Plot. I'll talk more about Observable Plot, that library for quick data viz as we go. So we'll be doing that in several different ways, using the chart cell or just starting from a code snippet. We will learn how to import a JavaScript library in our notebook so that we know that we have access to like any other JavaScript library that we might want to use in our observable notebooks. We'll perform and visualize the results of simple linear regression, and then we'll learn how to share a notebook link with external viewers. So we're covering a lot today. A lot of these are kind of essentials to get started with observable and working in JavaScript and some of the features that we'll use. But this is where we're going for today. So we're covering a lot. Okay, now let's meet the star of the show for today, which just delights me every time, which are marsh fiddler crabs. So marsh fiddler crabs are the characters of the data story that we are going to be exploring and visualizing today. We're going to be using data on fiddler crab sizes collected in marshes from Florida to Massachusetts along the east coast of the United States. These were collected by David S. Johnson, and then this was published in a paper that we'll come back to later when we start thinking about our insights in 2019. This was collected in part as efforts from the Long-Term Ecological Research Program, LTER, and shared openly through the Environmental Data Initiative. So this fiddler crab picture, I think the first reaction might be like, is its claw really that like giant, that one claw, or is this a perspective issue with this photo? No, it's not the perspective. They really do. Male fiddler crabs have one giant claw and one little claw. And the name fiddler crab apparently comes from kind of the arm waving and positioning that the male fiddler crabs will do during mating rituals to try to appeal to female fiddler crabs. So they truly do have like one gigantor claw that might look like they're playing a fiddle, maybe with their other little claw. Another cool thing that I learned about fiddler crabs is if in like a battle with another male fiddler crab, they lose their giant claw, then while that claw is regrowing, their other mini claw becomes the giant claw. And so they'll just like alternate growing mini claw into giant claw back and forth, always having one, which I think is just amazing. All right. Obviously, I could talk and think about fiddler crabs for a long time. Let's move on. But this is what we're going to be talking about. Yeah, no, not an illusion. Like just like actually what they look like. This is not a perspective thing. So today what we're going to be exploring is relationships between a couple of environmental factors like water temperature and air temperature and latitude on sizes of male fiddler crabs. I also just really enjoyed this description of crab collection data, which is that these adult male crabs were collected in 2016 haphazardly at low tide. And this last sentence cracks me up. Crabs were collected by hand from the surface or by coaxing them to the surface by placing a trowel or finger beside their burrows. So I haven't tried crab coaxing myself, but in my head, that was just a delightful image of researchers coaxing fiddler crabs out. Okay, let's do it. I think we should go ahead and get started. So in the chat, there is going to be shared a notebook, an observable notebook. And what you all should do is click on that link, and then that will take you to a notebook that looks like this. So I'm going to give everybody a minute to get there and make sure that that link gets shared in the chat. So this is the one that you'll be following along with. What this contains in it is, this is an observable notebook. So while folks are getting set up, then cool, thanks. Okay, so there's the notebook, that blank notebook that you're going to follow along with. When you click on that link, it should take you to a notebook that looks like the one shown on the screen here. So everyone has it. There's a session one slides that I'm walking through, and you can also see the link to the key. So you have access to all the materials, including the key for this entire session. So if you have in your observable notebook, if you have an account, then you're able to fork this notebook. And that's what everybody should do so that you can make your own copy and so that your changes will be stored. If you don't have an observable account, none of the changes that you make will be saved here. So definitely want an account. Again, you can sign up for free and make sure that you can get to this. And we want to make sure that everybody can store their own copy. Okay. So what we're looking at here, in case this is your first time using or testing out an observable notebook, welcome to an observable notebook. So an observable notebook is a web-based computational notebook where you can combine text and code and outputs from code and add interactivity. And the really nice thing about working here is you can do all that, and it's very easy to share. Since you're creating things on the web in the language of the web, then you can share this with other people just by sending them a link. And we'll see how to do that at the end of the day today. But I did want to go over a couple of basics as we get started. The first thing that you're going to do before I start showing you how to do anything is go ahead and fork this notebook. And the way that you do that is up here in the top right of your notebook, you can see the fork this notebook button, that little forking icon. And when you click that, then you can select which account you want to fork this to. You might only have one, like your personal account and workspace, and that's fine. So go ahead and fork it. And then what that will do is that's going to transfer you over into your fork. You'll see up here near the, just above the title, it'll say fork of that blank version of the notebook. And then you'll know that you're working in your own fork. So go ahead, I'll give everybody a minute to go ahead and make sure that you have that notebook forked. All right. And if you have issues, please let us know. We love to hear about issues so that we can, yeah, make sure things are running smoothly and see if there's anything we need to change for our next sessions. But hopefully forking went smoothly. Not seeing any like panic emojis. Okay. All right. I think we'll go ahead and get started. Okay, congratulations. You did step 0. Let's move on to step 1, which is just going to be a very brief overview of some essentials that are going to allow you to follow along with what we're doing today in case you haven't worked in Observable before. So, okay, good. It sounds like some folks didn't have any issues. Awesome. Thank you. So when you're working in a notebook, the way that you add content, whether that's text as Markdown or HTML or JavaScript would be a big one for us, or specialty cells, you're going to add those in different cells. So every single piece of content that you see here in this notebook is in a separate cell. And I can always look and see what's actually in the cell, like in its raw format, by clicking this little arrow to the left of any cell. And you can see that that'll open the edit cell view. So you could see what this actually looks like. So this is a Markdown cell. This little icon indicating text indicates this is a Markdown cell. I can see that I have Markdown, which is plain text with some formatting added to create this header, and then a bullet pointed list using a dash followed by a space before each list item. So we can, so all of the content that we see here and all of the content that we create today is going to be in a separate cell. But we can add different things. Like this is a Markdown cell, but we might want to write JavaScript, and that's in a different cell. Or we might want to create a specialty cell, and that's in a different cell type. So the way that you can add cells in Observable notebooks is, see where you see this little gray plus sign in the left margin? That's going to exist between any cells in your notebook. And so you can choose where you want to add a new cell. And once you click that, what opens up is the add cell menu. And I'm going to refer to this a lot today. The add cell menu is where you can choose either the type of cell, of blank cell that you want to add, or you can choose some existing code snippets that provide helper code to get you started, or specialty cells like adding a data table, which we'll use later on. But for example here, if I choose JavaScript, then you can see that this cell comes up between the cells where I press the plus button. And I could start typing JavaScript like 2 + 2. Nothing is going to happen until I run this, but I can do that a couple different ways. I can do shift return, and that'll run it. So I can see that the output shows up above the cell, or you can always press the play button on the right-hand side. So this is how this add cell menu, go to the add cell menu, make our selection. That's going to be something that we do a lot throughout the day today. And then we can run code. Again, the shortcut is shift return, but we can also press that run button. And the only other thing that I wanted to show today is on the right margin, and let me see if I can view this. Yeah, let me move my face for a second. Okay, so in the right margin, moving everything besides my face. Okay, let me see. Nope. Okay. Well, I'm just going to move this screen for a second. But on the right margin, you can see these different icons. And we're going to be using one of these mostly today. We'll check out others throughout the course of this workshop series. But this top one is the files pane. And this is where we'll see today, you can choose to add file attachment. You can link to cloud files if you've added authorization. So just when I refer to the files pane, I'm referring to that little paperclip pane that we can open to attach files there. Okay, so I think that actually gets us through, let me just move this back up a little bit. I think that gets us through kind of the essentials that you'll need to know to get up and running with this session today. So let's go ahead and do it. Let's get some crab data. All right. So we're going to use this crab data, which is not already attached in the notebook. And that's intentional because I kind of wanted this hands-on workshop to be like end to end from accessing data through sharing it with somebody on your own. So you feel like you can truly like independently work in a notebook to do some data work in JavaScript and Observable. So if you click on this link, the download the crab data, that should download the data set that you're going to be using to your device. It's going to be saved as html fiddler crab body size.csv. So this is a comma separated value file. So go ahead and click that and make sure that you have that file downloaded somewhere that you'll be able to find it. This is like my biggest finger crossing moment is that this link works for everybody to get the data. So let me know, let us know again if you have issues getting this data downloaded, but hopefully it's pretty quick for everybody. All right. And if you're wondering where this came from, this is the actual CSV that's shared on the Environmental Data Initiative repo for this study. So we are getting the exact data that was uploaded and shared by David Johnson that goes along with that 2019 paper that was published. All good? Cool. Thanks for the updates. Okay, so this is where, so the link for this file is on this purple button. So to download the crab data, you can just click on that and that should download that data for you. All right. So now what we're going to do is we are going to attach this CSV in our notebook. And again, each session of this workshop, we're going to be using a different like path of data science workflow options. Today, we're using the attach local file in your notebook option, but you can also pull data directly from cloud files. You can connect to databases. You can access data from APIs. So there's a bunch of options. Today, we're doing the local file in our notebook version. All right, so if I go back to my files pane, and this is what I want everyone to do, is you can go ahead now, and if you go to your files pane, and let me minimize this again. So if I go back to my files pane, then if I click on my files pane, a new screen is going to open, a new little modal is going to open that gives me an option to attach my file. Okay, so to the right of file attachment, right where my face is, you'll see a plus button. And if you click that, then that's going to ask you, and you're not seeing it here because it's not the window that I'm sharing, but that's going to get you to like your navigator where you can then go and find the file that you've downloaded. So go ahead and find that file. So go to the files pane, press that plus button, and then navigate to the file that you just downloaded and click open. And then you'll see once you've done that, that in my file attachments pane now, I can see this HTML mar fiddler crab body size CSV is attached. And it also tells me this is currently unused. So this is hanging out, it's attached to my notebook, but there's currently no code in my notebook that's actually using anything from this data. All right, sounds like people are getting things attached. Cool. All right. Another thing that you can do, which we won't do here, but another option is that if you have like your Finder error open, then you can just drag your file over towards the file pane and it'll automatically open that modal and you can just drop it in there and it'll attach. So that's another kind of quicker version there. So if you have a privacy error, make sure that you're in your fork. So it should be in your account, your observable fork to your observable account, and then you should be able to upload a file there. Okay, so hopefully everybody's able to attach this file. You can see that now in your files pane, a little number 1 there, indicating that we have one file attached. I'll click that, that'll close it. But let's say that I want to actually just take a quick look at this data. There's a really cool feature where if I open the file pane up again, so again, clicking on that paperclip, you can see there's an icon to the right of that file that says insert into notebook. And here, if I click that insert button, then you can see that what shows up is a nice interactive data table cell. So I'm going to do that one more time because that was a little bit quick. So here's another important thing. If you want to delete a cell that you've added, you can go up to the vertical 3-dot menu for any cell in the left margin, and then just scroll down to delete, and you can delete it. There's also shortcuts for a lot of these things, but we'll use the GUI options for quite a few today as we get started. But again, if I want to take a quick look at my data in tabular form, I can go to the files pane for this file. It's currently unused. I can click on this insert into notebook option, this little icon, and that automatically is going to add what's called a data table cell. So here, one thing that you might notice is your cell might have shown up in a different place than mine in the notebook. But we can always move things around in a notebook too. So here, I'm just gonna, again, go into my 3-dot menu. If I click and drag, then I can drag that up to wherever I want it in my notebook. So it's pretty easy to move things around. I'm gonna move this into my step 3 because that's actually where we are. And then I can take a look in the data table cell to start doing some initial exploration. All right, so hopefully everybody was able to insert a data table cell. I'm going to spend just a minute or two chatting about this because I think this is a really powerful way to get to know your data because it's really critical to always inspect your data, look for fishy things happening, get a sense of what variables are there, the classes of variables. So what do we notice here? So this is pretty cool. Not only do we get a very quick tabular view of the data, but this is also interactive. So for example, and we can see we have variables like date, latitude, the site along the East Coast. When in that map on the slides, there was these 13 different sites. So we have different sites indicated by abbreviations. There's different replicates just indicating the individual crab ID at each of these sites. The carapace width, that's the width of the crab shell that's getting measured. That's in millimeters. We can see it's a number here. So this is parsed as a number. These abbreviations are maybe not totally intuitive, which is why we're going to be doing a little bit of data wrangling and cleaning. But what these MATA, SATA, MATW, and SATW are is MATA is the mean annual air temperature in degrees Celsius for that site. SATA is the standard deviation of the annual air temperature at that site. And then MATW and SATW are similarly the mean and standard deviation of the annual temperature, but for the water. So these are the environmental conditions in addition to latitude that we're going to be exploring today to try to see what's going on with crab sizes. So we have this data, and again, this is interactive. So in the data table, so it's really nice is like, let's say if I wanted to look at just the distribution of carapace width for the VCR site. Um, if I click on that site bin in the data table cell, a really nice thing happens, which is that the rest of the distributions that are shown across that top bar of the data table cell are also updated to show me how the distribution just within that site compares to the overall distribution for the entire data set. So you can choose one, you can choose ranges of things, like I can brush across multiple bins of carapace width. So I can do a lot of kind of exploration through interactive tooling around right in the data table cell. If I'm like, nope, just get me back to nothing selected, you can click this reset and that'll go back to everything included. But it's a nice way to get to, oh, I see a question here that I do want to address because that's confusing. I'll get there in 1 second. Click reset in the data table cell, and that'll get you right back to like everything being shown, nothing selected. There's a question in here, import show me from in the appendix. You'll see that line. That's because I forgot to remove that line. I was going to include some show me buttons to reveal code, but then with the data not attached, you just get like a bunch of errors in the notebook at the beginning, which looked scary. So decided not to use it. But yeah, that's not actually getting used. So nothing's being pulled in until it actually gets used in code. But we'll see in future sessions, imports are awesome, and we'll see how we can use them to get materials from other people in the community so that we can quickly reuse and repurpose our own work or what other folks have used. Good question. Okay, so we could do some wrangling here. You might notice in the data table cell that there's options for like filtering the data and selecting columns and sorting and slicing to only pick specific rows. So you can do some wrangling here and then save that. So you could save like a wrangled subset, which is really awesome. What I want to do is actually start doing a little bit of data wrangling in JavaScript. So let's take a look first and see what I'm going to rename this, like this name. You'll see that when you insert something using the data table cell, the automatic name that's given, which is in this kind of first cell in the bottom blue section of the data table cell, that is kind of named based on the original file name. But if I just want this to be called crabs, then I can just rename it there. And again, if you press run, then this is updated to be named crabs. Does a file contain, I see a question here, does a file containing data become a database? Not necessarily, but you can add it to a database. You can, using WB client of, and maybe Robert or Wayne can share a link, you can actually create your own database right in a notebooks and then write SQL queries on it, also in Observable. So you can add it to a database. All right, so I've renamed this crabs. We have these variables that I already went through. But a couple of things that I notice about this are maybe like, actually, I'm not going to use all of these variables. So I want to limit the number of columns that I have. I want to rename some things to make them a little bit more intuitive when I'm doing my work later on. So I might want to do, even though this data is tidy already, like each observation is a row, each variable is in its own column, each cell contains a single value. So these are like capital T tidy data. I might want to simplify it a little bit, make some things a little bit easier for me to work with and remember later on. And the way that we're going to do that is by writing some JavaScript code. But first, we should ask ourselves, like, well, what is crabs? Like, what it shows up in the data table cell, but how is it actually stored? Because this might be, if you've been working in pandas data frames or in R using data frames, this might be a little bit of a different structure. So I'm going to go ahead and just see what crabs looks like outside of the data table cell. So I'm going to insert a new cell here and choose JavaScript. And then I'm just going to type the name of that thing. And this reveals the actual structure of crabs. And if you get a message here that's like crabs is not found or like error crabs does not exist, remember that up in this data table cell, I changed the name in that first little cell in the bottom blue section to crabs and then ran that. And that's going to update how this is stored. So I call crabs down in a JavaScript cell. And I can see like, oh, this tells me that this is an array that has multiple objects in it. So here, if I open this and I can expand that array by clicking this arrow just to the left of array, if I expand this, then this will actually show me what this array contains. An array in JavaScript is a data structure that can contain different elements that don't have to be the same type. In this case, our different elements that the array contains are objects. And what objects are in JavaScript is objects are a way to store values alongside a key, like a property name. So hopefully you see when you open that array, you can see that there's all these different properties for each of these objects, where each of these objects is a record for an individual fiddler crab. So we could see we have these properties: date, latitude, site. Notice here, this is one to keep an eye on. Site here in this data set actually has a space after the name. So just be aware of that, because that's going to change how we do some wrangling on it. And then we have carapace width, and then these other environmental conditions. So we have an array of objects that we're going to be doing some data wrangling on in JavaScript. So I think let's go ahead and try it. I'm going to be explaining this code as I walk through it. If this is your first time writing any JavaScript code, welcome. It's going to be great. Okay, so first things first is we need to insert a new JavaScript cell. So I'm going to go ahead and insert a new JavaScript cell. Again, I'm going to the Add Cell menu, choosing JavaScript, and then I have a blank JavaScript cell. And what I'm going to do is I'm going to make a new version of this just so we're not overwriting things, just for kind of linearity in our lesson, that I'm going to call crabs.js. You call it something else, you call this crabs clean. I recommend, if you're following along, just call it the same thing as I do, because I'm going to refer to this later on. So I recommend sticking with the same naming conventions that I am. But you can, if you do something different, just remember that throughout the rest of the lesson, you're going to want to use that name that you chose. Okay, so what I want to do with this array is a couple of things. I want to iterate over each of the different levels, each of the different objects in this array. And I'm going to do a couple things. For each different object that I iterate over, I want to return just a few of these variables, so not all of them. And I want to rename them to be more manageable for me to use later. So this is like, if you learn one thing in JavaScript for data wrangling, it's map. If you use a second thing, it's like filter. But we're going to use the array map method. And the job of array map is to iterate over each element in an array and then return some output of a function. Our function is going to be returning those renamed properties that we ask for. So here's what this is going to look like. I'm going to start from crabs. That's my array of objects that we see above that has all of our different crabs, but with names that we don't love, maybe. And then I'm going to apply the map method using .map. So this might look different if you're working in Python and you're used to like dot chaining. This will look familiar. If you're working in R, maybe you're used to like the pipe operator. We use dot here. So this is saying, starting from crabs, I want you to iterate through each object in that array. And then what we need to do is say, here's a function where what I want you to return in a new array is the output of this function. Here's what this is going to look like. If you haven't used this before, it's going to look a little bit weird. I remember when I first started learning JavaScript, I was like, what is happening? So I'm going to start by writing this, and then I'm going to tell you what this is doing. So what I'm saying here is this is what's called arrow function notation or arrow function expressions, which is just a concise way of writing a function, where D here is the input parameter. This would be like the same as if you wrote like function of D, and then you would say like return mean of D or something. But here you're just saying the input parameter is D, and here's what I want you to return from that is going to be on the right hand side of this arrow function operator. Okay, so what we want to return, and careful with parentheses and braces, just in general in JavaScript, but especially here, I'm going to add a new set of open and closed regular parentheses, and within that, a new set of curly braces. So what this is doing is those innermost curly braces are indicating return an object. So we're going to return an object that contains these different properties that we add. We have an additional outer parentheses here because when we write a function like this, curly braces can be used to indicate different things in JavaScript, like another function that could get returned, for example. So putting this additional set of regular parentheses outside of those curly braces lets this function know when you return the new array, what it should contain is an object, not a function, not something else that can be started with a curly brace. Return an object. So that's what we're doing here. And now we're going to get to, okay, well, what do I want each of those returned objects to actually contain? What we want them to contain is we want them to contain just 5 variables. Those are going to be the latitude, the site abbreviation, the carapace size, air temperature, and water temperature, the mean air temperature and the mean water temperature. And we also want to rename those at the same time. I think this is kind of cool because this is going to be like a select and a rename at once, but you could also in here do like mutate to add a new column. So there's a bunch that you can do right within one map statement in JavaScript. So here, this is where I'm going to start saying what properties do I want this returned object to contain. So here I'm going to say I want it to contain a property that I want to be called lat. This is going to be my simplified latitude property. And to access that, we're going to use dot notation to access this variable. So if you're trying to access a property from an object, you can give it the object dot and then the property name to get it. So here I'm going to use D. Remember, that's iterating through each of our objects. So this is going to say for each object, that's our input parameter for this function, I want to access. So I have dot, and then I'll give it the original name that was in that array of objects. So let's see what happens if we just run this. Again, you can use shift return or you can press that play button. But you can see when you run this that you get, again, an array of objects. But if you expand that, then what you'll see is that it only contains a single variable, which is the latitude, now renamed as property lat. So that's how we can use the map method, iterating over each object in an array, give it a function where that function is returning a new object that only contains the latitude with a renamed property of lat. So there's actually a lot going on in one line of code. But we don't want to just return latitude. We want these other 4 variables that we want to include too. So we're going to add this still within this returned object. So still within these 2 curly braces, separated by commas. So you can also press enter and that should automatically indent. But I have a comma after latitude, I've pressed enter, and now I can add the other variables that I want to return. So here, if I want to rename site as site, I'm going to say I'm going to store a property site in these returned objects, but I'm going to do something different here. We're doing a lot of JavaScript in one little example, which is awesome. So if I try to do d.site and I don't get an error. But when I look at this array, I see that site here is undefined for all the values, which I know like it's not in crabs. Site has characters, has abbreviations for all of the different sites. So any ideas that folks want to share on why when I use this dot notation for site, why am I getting undefined for all of those different values for site? Pop quiz, put it in the chat. Let's see if folks can think about what might be happening, and if folks have used JavaScript, how might we update this? If you don't know, that's great. That's why we're here. I'll show that in a second. Yeah, the space. White spaces can be such a bummer. Exactly. So site space is seen as a completely different property than site with no space. So here, because data class, I'm really glad that you said that. This one is the extra space, but we got a couple of comments about like variable type and data class, which is also just like an excellent thing when you're like, I don't know what's going on. This seems fishy. Data class is like one of my top things to look at. So also great suggestions. But yeah, here it's because in our data, if you remember, if I look back at this object or at this array, you can see that site here has that space after it. Now, how can I include that in my data wrangling? This is where we're going to have to add something a little bit different here. So we're going to use another method to access a property from an object, which is bracket notation. So using this dot notation, good. Okay, so I'm seeing some suggestions. Excellent. So this dot notation, this works great if you have like compatible names of variables, like no spaces, no expected punctuation, like things that are in like just words in camel case or snake case, no space, no unexpected things, then you can use that here. But you can have variable names in JavaScript that don't follow those conventions, that have spaces, that have unexpected punctuation, for example. Yeah, so I'm seeing the suggestions here that are going to work. If you ever are trying to access a property from an object where the property name doesn't follow kind of those conventions needed to use dot notations, then we can use bracket notation. And the way that we do that is just immediately after our little D in this case. Wouldn't have to be D. We could have D be apples if we wanted to, as long as we're consistent with how we're referring to that parameter. But we can use bracket notation here, and then within quotations here, we can give it the full site, the full property name, which in our case is site followed by a space. This is capitalization sensitive, so make sure that you are capitalizing site here. We're renaming it to site down here. Yeah, changing the name in the original file is an absolutely valid option. You could also, you might have noticed in the data table cell, you can rename things, which is cool. So there's a bunch of options for doing this. If you wanted to do it here, this is a way that you could clean up that site property with a space in it. And now I'll see when I run this, that when I look at my array, now I have my latitudes and I have these sites that are no longer missing because I'm actually referring to the full property name that was in the crabs data. Okay, so what I'm going to ask you all to do is I am going to ask you to do a couple things on your own. What I want to do right now, we have an array of objects that contains two properties, lat and site, but we also want to contain the carapace width, mean annual air temperature, and mean annual water temperature. So what I want you to ask you to do is also access the carapace width renamed to size millimeters, meta renamed, that's the air temp to air temp C, and MATW, which is the mean annual water temperature, renamed to water temp C. So go ahead and take a minute and you can look at like, okay, do I need to use dot notation? Do I need to use bracket notation? You can always use bracket notation, even if it is just like a one word no spaces. But go ahead and try adding these other renamed properties into that map method so that you end up with an array of objects that has these 5 renamed properties. And I'll give everybody a minute or two to go ahead and add those, and then I'll walk through it too. All right. So hopefully people have had a chance to at least try adding one of those. I'll go ahead and add these. I'm going to give it the new name first as the property that I want to return. So here I'm going to return size millimeters, and that's going to contain the existing values in carapace width. I'm also going to add air temp C because it's in Celsius, and that's going to contain the values in the current MATA variable. And I'm also going to have returned water temp. I'm going to call water temp C, and this is going to contain whatever exists in the MATW variable. And you'll see that when I run this, after I think it gets to 3, but Robert or Wayne or other folks on the call, correct me if I'm wrong. I think once it gets to like more than 3 arguments, it'll automatically organize it in this nice vertical arrangement for you. So I can look at this and see, okay, now I have done a couple of tidying things that I can go ahead and check out. I have these 5 variables nicely renamed. Those air and water temperature variables, I feel a little bit are a little bit more intuitive, so I'm less likely to like have to go look at a data glossary every time. So this is a way that you can access. So this would be like a select and a rename if you're used to doing things in R and pandas. But just to kind of like show how versatile this can be, what if I was like, you know what I really want to do is I want to convert like the size in millimeters, that I want that to be actually divided by 10 if I want to convert it to different units, right? I can just like do that right in here too. So I can go ahead and do calculations that actually would calculate new values for me. So you can use within the array map method, do like many data wrangling steps, rename, select, mutate, like you name it. map is often what you're going to be doing to return like a new and updated wrangled version of an array of objects. Okay, so there's a question. Oh, okay. So there's a question. What would be an example full statement to see the object keys? Yeah, great question. So let's take a look. So if I wanted to look at in crabs, what are the object keys? I think this is what the question is. I can do, I'll insert JavaScript code. I can do object keys, and then I can look at the first for example, object, which uses JavaScript uses zero indexing. So I can go ahead and look at the different names, and I can see that site here has a space in it. Cool. Okay. See other good questions. All right. Oh, fancy formatting. Okay, I see a question about how do I automatically format? Yeah, again, I'll ask Robert and Wayne to correct me if I'm wrong. There is an option in observable settings to like prettify your code. If you're working in, for example, observable plot, and we'll see an example later, Option Shift F will prettify the code. So break it up into more vertical organization, I think. So somebody fact check me, please. All right. So cool. Now we've done some data wrangling and actually learned like a lot in this one example, right? Like in this one, this is what I love about JavaScript is, yeah, there's a lot to learn to work with data, but also like with a pretty small number of skills, you can do a lot. Like in this one example, we learned about array map. We learned about the arrow function. We learned about dot and bracket notation for accessing properties from objects. And we learned how to rename things. So I think like as you learn more JavaScript, you can really do a lot with a pretty focused skill set. Okay. I also am noticing that I did my wrangling for step 4, actually in step 3, but remember we can always move these sections. So I'm just going to grab this cell, again, using the 3-dot menu to the left of this cell, and I'm going to drag that down to doing this data wrangling in JavaScript. Cool. So I can rearrange things. You can also, we have shortcuts for moving things around. So once you start working in observable notebooks more, you can become really nimble at kind of the different ways that you can navigate around notebooks and move things. Okay, now we're going to get into data visualization. So now we've got this slightly cleaned up data set that has the latitude, has a site name, has the crab measurements in millimeters, air temperature, and water temperature. Let's start visualizing it. So now what I'm going to do is show you 2 different ways to get started with a chart in Observable Plot. If you haven't heard of Observable Plot before, it is awesome. Observable Plot is a data visualization library built on D3 by the team that built D3. But if you worked in or tried learning D3 before, it's wonderful if you want to like truly build from scratch every single piece of a data visualization. And that's why it's great, is because you have complete control over every single thing. So you can make these really artisanal, amazing custom data visualizations from absolute scratch, piece by piece. So you'll see it a lot in like data journalism and yeah, really bespoke visualizations. But one thing that also means is that since you're building things up from scratch, that might mean to make like kind of a standard chart, like a bar chart, maybe that's like 40 lines of code. So what Observable Plot does is it adds 1 layer of abstraction to allow you to more quickly create some of these like standard chart types, but it's also fully customizable. You can extend it to use D3 on top of it. And like we'll see maybe today, but definitely in the next sessions, really nice for adding interactivity too. So we just start kind of at a place closer to the charts that we might want to create. And I'm going to show, after I drink some coffee, one sec. Okay, I'm back. I'm going to show 2 ways. I encourage you all to drink coffee too throughout the day today. I'm going to show 2 ways that we can get started in Observable Plot, which is one, using a really recently added feature in Observable, the chart cell, which lets you get up and running creating charts with no code, but then gives you the option to eject to JavaScript so you can keep customizing it in JavaScript, which was really cool. Or you can start from a code snippet for a chart type that you know you want to create. So I'm going to show both today. And we'll learn about like the structure of observable plot code along the way. That's a thing that we're going to come back to repeatedly, or like in this session and in sessions 2 and 3 of the workshop, is how we can start building up and customizing data visualization and interactive data visualization with observable plot. So observable plot is built on, again, built on D3, inspired by the grammar of graphics, which means that to create data visualizations, you're really building up your charts layer by layer, specifying marks, like how do you want the data to be represented? Is that as dots? Is that as a line? Is that as bars or cells, for example, and then adding like scales for customization, doing transform, and updating things like aesthetics. And we'll see different ways that we can start creating those. And we're going to start with the chart cell. Again, this is a pretty new and very cool feature. So let's go ahead and use it. So to use the chart cell, you're going to click on the Add Cell menu. And the Add Cell menu, one thing that we haven't seen before is that this is searchable. So once I open my Add Cell menu, if I just start typing chart, then I can see that the first option that comes up is chart to make quick plots without code. And that's going to create this specialty cell type. So again, just in case anybody missed this, to use the chart cell, what I'm going to do is I'm going to click on my Add Cell menu. I'm going to start typing chart, and then I'm going to select this first option, which is going to, again, insert a new cell. This is a specialty cell type specifically to make a chart cell. And the first thing that we need to do is select which data we actually want to use when we create this visualization. So I'm going to choose, and you all should too, I'm going to choose that slightly wrangled version, Crabs.js, that we created. And once I choose a data source to use, then you can see that you're giving these different options for selecting variables, colors. You can map things like a dot radius onto a variable. You can choose to facet, you can change the mark, and you have options for customization. So I'm going to show you one thing, and then I'm going to give you a chance to play with this because it actually is like really fun. So I'm going to choose on my x-axis, for example, I'm just going to choose size. So I'm just going to choose the crab carapace size variable. So here, if I just choose size, then notice that what the chart cell does, if you've only selected a single variable, is it produces a histogram showing you the distribution for that single variable. And if that's all I wanted to do, I could change like the color of this. I could do some customization on this. So if you go to the customize button, I could increase margins. I could change the figure height and width. I could change the X and Y axis labels. And I could change my color schemes or add a caption. So I can do quite a bit of customization just right here. So maybe I'll just like change the X label here, because this is like the kind of thing that I always forget how to do. So I'm going to say carapace size in millimeters. I'll write it out in millimeters. And I'm also going to, yeah, that's all I'll do. So yeah, it's cool, right? I know. It's very cool. So I've updated my x-axis label. Now I can see that my x-axis label is updated to carapace size in millimeters. But I can also choose other variables that I might want to compare this with. So for example, I could say, you know what else I want to plot this against? And notice that this is making decisions for you about like what chart type would make sense given the variable type and how many variables you have selected. So based on some simple heuristics, observable plot here is making like some assumptions about, I think this is a reasonable chart type, but you can always change it. But let's say I want to plot size against air temperature. Well, once I do that, then you could see that this automatically updates to a different chart type, which observable plot, not like in its brain, but like based on the heuristics, the chart cell creators were like, this is a reasonable chart type. And you can see that now I have a plot of air temperature versus carapace size. This is not meant to say this is a good data visualization. It's not. So you can see that we have these different values for carapace size and air temperature. And I could always switch these. Like I'm going to switch this to, actually, I want air temperature to be on the x-axis and I want carapace size to be on the y-axis. But then I didn't do my swap x and y, which is an option there. Then my x label is actually wrong. So I'll just update this to air temperature in Celsius. So we can very quickly start making these graphs with no code at all, which is great for like getting started, exploring if you're not sure how you want to look at data. Another cool thing that's really nice is that this already has tooltips added. So this is already an interactive visualization. But let's say that we wanted to actually customize this in ways that are beyond what exist in this built-in customization menu in the chart cell. We can do that by, if we click on this new option, this option down here for the add cell menu, you can see that there's an option that says, I have a suggestion for cell 59 that I think you might want to use. And that is to convert this no code version of this chart that you've created to JavaScript. So let's see what happens when we click that. Well, first what it does is it copies. You can see that you have the chart show up twice. But now, instead of having just the like GUI interface for making selections, we can actually see the observable plot code. So this is the actual JavaScript code using the observable plot library that you would write to create that same chart that we saw in the chart cell above. I love this for a number of reasons. First, because I think like just being able to quickly explore different versions of a chart visually is really nice. Second, I love it because I think this is a great way to learn observable plot and still feel like making progress because you can create charts using the chart cell, but then look and see what that code would look like in JavaScript just using that eject to JavaScript button. So here, what am I looking at? I'm going to break this down a little bit, and then I'm going to let you all play with it a bit. So here, what I have is this first line of code. This is using observable plot, and this is just like initializing a plot. It's like, hey, heads up, we're going to be making a chart in observable plot. And then the other big part that I wanted to focus on is this marks section. So within the marks section, we say how we want our data to be represented visually on like the canvas that we're creating. So in this case, we're using dots. Notice that this doesn't specify a specific chart type. It specifies the mark, and that makes it more flexible because otherwise you can imagine if you had a different chart type for every different possible chart, you would have like thousands of options, when really like it's much easier to just have a more limited set of marks, and then you can customize those to create different chart types. For example, we can use plot dot to make a basic scatter plot, but we can also use plot dot to make a bubble map. So we can customize this based on a smaller set of marks to create this vast number of different chart types we might want to create. But here, this marks section is where we can add one or more marks that we would want to show up. In this case, plot dot, that's going to create our scatter plot here. The first argument is the data that we're accessing those marks from, the coordinates for those marks from. And then we can give it X and Y. Now, there's more in here that we don't necessarily need. So if I delete everything besides what's in that mark section, so if I only have the mark section with my plot dot, here's the data, here's X and Y, then we have just this kind of standard points in black, no updated labels. So this would be like kind of the baseline plot that we could customize. And we could also add stuff back in here, but a couple things that again you could learn from doing the customization in the chart cell are things like the stroke is the outline color here. I'm going to make this look really awesome. I'm going to make it orange. The fill color I'm going to have be purple. If you're working in other data visualization tools, sometimes the dot size uses size. But here we're going to have it uses R. So for the radius, so I'm going to say 9. This is looking great. I can like feel Robert Cassara on this call just being like, Allison, don't. But you can see that once you have a base plot created, and once you know the option names, you can just continue updating different properties based on either a constant or based on a value. Like if I wanted the radius to depend on the water temperature, so if I wanted it to depend instead on water temperature, then I could just give it that water temperature variable accessed from the different objects. And it's hard to see here, but you can see that the water temperature actually, those dots are getting larger as you move to the right, where the air temperature is also higher, which makes sense. But I'll change it back to a constant just for the sake of this terrible viz. Yeah, opacity, good question. If you have a lot of points, it can be really useful to add some opacity. That one's nice because it's actually just opacity. So that ranges from 0 to 1, where 0 is completely transparent, 1 is completely opaque, and then anything between 0 and 1 is going to be some level of increasing opacity. And if you have did I disappear? Hopefully I'm back if I disappeared. What I want to say is like maybe about a month and a half ago, a brand new plot document website was launched that has just like tons of examples, overviews of the different marks. So it's really nicely documented on the new Observable Plot site. Oh yeah, so what does tips do? Man, we're getting to talk about a lot of cool new features here. If you add tip true to a mark, so if I do tip true, notice here, well, just to really put a point on this, no pun intended. Right now, if I hover over these points, I don't have a tooltip showing up. But another pretty new feature that's just added is a tip mark. So one way you can add tooltips into an observable plot chart is to add tip true. And just doing that will come up with a tip that hovers over, showing the coordinates of each of your points. You can also add a custom tooltip mark that you have control over, like what variables are included, what does the title look like, for example, so you can customize it. And there's also a cool mark, crosshairs. which is awesome. Where, for example, if you have like a line chart, we'll create crosshairs, a vertical and horizontal line that tracks where your point is, which is really awesome. Yeah, so check out tooltips too. We'll do more of that in the next sessions also. All right. So yeah, so observable plot, if you worked with other data visualization tools that kind of follow the grammar of graphics, very similar feeling to the other to how you would build other types of visualizations. What I think is really nice, that let's just do an example because we can, is creating interactive charts is really, really nice. So I'm gonna show you a simple example to give you like a taste of interactivity with observable inputs. And then we'll use this for more like functionally relevant things in the upcoming sessions. But for now, let's say it is really important for my data exploration that I am able to interactively change the size of these points, which right now is set to an absolute value of 9. Let's go ahead and mix that up a bit. So here, what I'm going to do is right above this, I'm going to add a little widget. I'm going to add a slider bar where I can change the value of that slider, and that is going to be connected to the size of my dots. So I'm going to do that I'll click on this add cell menu, and then I'm going to search for slider because I know we have a range slider. And when I press enter, this always feels awesome to me. When I press enter, if it inserts this code with a placeholder, where if I run this, it actually is already a functional slider, which is so nice. There's also already like pre-built inputs for like radio buttons and text inputs and drop-down menus and checkboxes. So a lot of these are pre-built. You can also make your own. But right now, this is just like an out-of-the-box slider, but it's not connected to anything, right? So here, the default name is range. Maybe I'll change it to like pick size. And what's really nice about this is what this is doing, this input combined with view of, is that this one line of code creates the widget, reveals it to a user who can interact with it independently in their own browser, and stores the current value of that input selection. So here, just to show what this is doing, if I, in another JavaScript cell, call pick size, then what this is doing, you can see that that value changes instantly as I move my cursor along this slider bar. So then this is something that we can use because now we have a variable storing a value that's controlled by a widget where we can refer to that value by its name, pick size, wherever else we want to in our notebook to change an aspect of our chart, which is what we're going to do, to change a value that shows up in text, to change hues table. Like you can use these to update whatever other elements that you want, which is really awesome. So here what I'm going to do is I'm going to go down to my code. I'm going to make this a little bit smaller just so we can see what I'm doing. And instead of saying I want R to just be a static value of 9, I want R to be the current value. It's looking awesome. To be the current value of that pick size slider, which right now is 51. But you can see that because it's connected to this slider, I am able to, as I change this user interface element, as I scroll on this widget that we created in, like seconds, and then just call the value by name, I can update this and I can see that then my chart responds. This, okay, maybe not the most functionally relevant thing, but you can imagine that this can be really useful if you want to like zoom in on specific sections over time, or if you want to only visualize a certain subset at a time from a much larger collection of groups. Inputs are going to allow us to do that. And the nice thing is that we're always going to follow the same 2 steps, is that we are going to create our input. That's going to, again, have the input show up in our notebook nicely. and store the current value of the selections. That's step one. The second step is connect that to an element in our chart. And then we have instant interactivity, where if then you share this notebook, then a person would be able to independently interact with the visualization that you've created just by sharing a link, which is pretty awesome. All right, that was a little aside, but welcome to inputs. Oh yeah, so where did I pull that? Hi, Christy. Where did that widget come from? So these, again, to say these are observable inputs is what these are called. And if you go to the add cell menu, so if you click on that plus sign, and then if you, I searched for slider because I knew that was in the name. But if you just look for input, then you can see that there are many existing inputs that you can choose. Clicking on any one of them is going to automatically input that widget for you. And then you can refer to the name of that widget wherever you want to. So here, I just added one for color. The name is color. If I go down to fill, if instead of referring just to an absolute color of purple, I call it color, then you see that I have now an interactive way to change the fill color. So I can make that interactive. So we'll be doing more inputs later on, but yeah, the inputs are a really lightweight way to add interactivity. Cool. Okay, so one thing that I wanted to highlight looking at this data is like, yes, we're learning about plot and we're learning how to get data, wrangle data in JavaScript, take a look in the data table cell, use a chart cell to make a plot. Now we're making things in plot. So far, we've used the chart cell and ejected to JavaScript. You can also just write plot code. So once you become comfortable with observable plot, you might just be like opening a JavaScript cell and writing your plot code from scratch. But there's also an intermediate, which is where I often find myself working, which is starting from existing plot snippets. If I know what chart I want to create, so I might not need to use the chart cell, although I still do often, just because I'm like, I forget how to bin things. So chart cell makes that super easy, and then I'll eject to JavaScript. I did that yesterday and it was awesome. But you can also use plot snippets. So let's go ahead and I am going to insert, I'm going to click on my add cell menu, but instead of choosing the chart cell, I'm going to start searching for scatterplot. So again, click on that plus sign and then start searching for scatterplot. And then if I press enter, what's nice is that this will automatically insert placeholder code, like skeleton code that actually runs. So this uses, for all of you data science folks, probably like a data set that everyone just loves forever, right? Cars. But this populates with a built-in data set, cars. So we can see like this is working plot code. But what this does is nice is because this allows us to just make updates for our own data. So for me, I'm going to say just replace cars with crabs.js. I'm going to replace X with lat. And I am going to replace economy with size millimeters. So just replacing those existing values with my own property names and data. And then I have an observable plot chart out of the box that, again, I could quickly make interactive. Okay, there's a question in here. How can I customize the tooltip? And the tooltip, you can, if you just add tip true, like I'm just going to add tip true in this code, then it's not customized. But there is a separate mark that we can share the link to that you can add within your code. And there's where you have more options for customization. So you'll add a separate mark to create either a custom tooltip or those crosshairs. We can do more of that in the next sessions too. It's a good idea. All right. let's get back to these crabs. Okay, so we've been kind of stuck in like the coding part of this, but what we want to do is like understand something about fiddler crabs, right? I know we all woke up this morning like, you know what I want to know more about is marsh fiddler crabs. Me too. So we do see something interesting here, which is that these are the same species of crabs. They were measured, quote unquote, haphazardly by coaxing crabs out of their little burrows. Um, but we do see that it looks like as latitude increases, that we are tending to see larger crabs overall. And we're gonna talk about this a little bit more generally later. But yeah, inputs do rock. Inputs are the best. I agree. Inputs are like a thing where I felt like I had like magic as soon as I learned about them, and as soon as I was like, wait, I've learned how to do one, and it's the same 2 steps for any of them. Like, yeah, they're awesome. Um, okay, so oh no. 2 things I'm distracted by are wildlife and awesome code. And so my brain is like ping, 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 back at crabs. So what we do see here is this interesting trend, which is like maybe surprising, which is that as latitude increases, it does look like we're seeing this trend towards larger crab sizes for these adult male fiddler crabs. And if we're assuming that these were randomly sampled, then what could be going on here? But what we might first want to do is we might actually want to model this. We might ask the question like, okay, it looks like there is this kind of linear increasing trend in carapace size with increasing latitudes. Can we actually explain that a little bit more? Can we ask a question? Well, on average, how much do we expect a crab size to change with each degree increase in latitude? And that's what we're going to do next. These comments are awesome. Nicole, I feel you deeply. Okay, so let's go ahead, and the next thing that we're going to do is simple linear regression. Then we're going to see how we can add this to observable plot to actually show the trend line. And then we're going to learn how to share it. But an important thing here is that I'm actually going to be using a method or a function from a library, from a JavaScript library that doesn't automatically exist in observable. And this gets us to an actually important question that you might realize later on. So I'll just bring it up now. Is like, observable plot is a library. Why can I just use it in this notebook without like installing that library or module or attaching it or loading it anywhere? And that's because observable notebooks recommend by default a limited number of very frequently used JavaScript modules that are like automatically available to you in your observable notebooks. And those are things like observable plot, D3, Lodash, the verbs in Arcaro. So there's already some things available for you, but that doesn't mean working in an observable notebook that you're limited to those things that are already recommended in the standard library. But if you want to use a JavaScript library that's outside of that, then you're going to need to use require. And I also linked to more general information that we have on require, but this is what's going to allow you to essentially like load methods from other libraries in your current notebook so that you can use them. In this case, we're using a pretty commonly used JavaScript library, ml.js, which has a bunch of different methods for like regression, machine learning, things we'll use in the upcoming weeks, like principal component analysis, clustering, logistic regression. So it has quite a few methods for like standard data modeling that you might want to use. So that's the one that we're using today, even though we're not going to have like a test and training data set. We're just going to use simple linear regression to use ordinary least squares to estimate our coefficients so we can understand on average how much are crab carapace widths increasing with increasing latitudes. So within this, and notice like I like name this when I import it. This is sort of similar to like giving like pandas as PD, like giving it a nickname that you can use later on, or like explicitly referring to a package in R with like the double colons. So this is what we're going to use. We'll refer to the library as capital ML, and then we'll refer to the method that we're using, which is capital, which is in upper camel case or Pascal case, simple linear regression. So let's go ahead and do it. So in order to do this, what we're going to do is we are going to start a new JavaScript line. I'm going to call this crabs LM for crabs linear model. A requirement when you're using the ML methods to get an output is you give it this little new piece. Otherwise, you'll get a message just like must be specified as new. And then we write out this function that we're going to use, which is from the ML library that we now have loaded as capital ML. Use the simple linear regression method. Notice that there you should see a helper little module where you can choose and then enter tab complete. So simple linear regression. And then the way that this is going to work is simple linear regression expects an array of values for X and then the corresponding array of values for Y. And that's what we need to feed into this separated by commas. So how are we going to get just an array of values? This is where we're actually going to use map again. So we used it previously to create like a new subset of our data that was renamed that had different properties. Here we're going to use map just to pull an array of values. And I'm going to show you below. I get an error here because this is incomplete. That's okay for now because I just want to show you how we're going to get these arrays. If I use crabs.js map and then just ask it to return the values of a single property like dlat, then all this gives me, notice that this is no longer an array of objects. This is just an array of values. This is, and you can see if you're asking like, why are these all 30? They're actually not all 30. If I keep looking, you'll see that there are different latitudes, but each site here only has a single latitude recorded, which is why we see both those like vertical alignment of points with latitude, but also why we're seeing these repeated values for latitude here. So here, what I'm going to do, so that's how I can get an array of values. So I'm going to have my first argument within simple linear regression be an array of values for latitude. We're going to say that's our independent variable. I don't think latitude depends on fiddle or crab size, but who knows what I'll learn tomorrow. And then we're going to have our dependent variable be crab size. So to do that, and you could split this up into multiple cells if you wanted to. So you could like specify just the array of values for latitude separately and then call it in here, but I'm going to do it all in one place. So my first argument is going to be my array of latitudes. So I'm going to have crabs.js.map d latitude. So that's my first piece. That's my X. Those are my X values. And then for my Y values, I'm going to have crabs.js map. Again, that's iterating through every object in crabs.js. And I want this one to just return the values in size millimeters. And once we do that and you run it, then you can see that right above that the estimates for slope and intercept, where intercept is not really a meaningful thing here if we're trying to just interpret it on its own. But that slope is the one here that we might be interested in. So the slope here, what is this doing? This slope, remember slope, if we're looking at a chart, not a Cartesian coordinate system, the slope is rise over run. So the average change in Y per unit increase in X. So what this tells us is that on average, given this data, we expect about a 0.485 millimeter increase in fiddler crab average carapace size for each 1 degree increase in latitude. That's what this slope piece is telling us. Now we can call those separately. So we can, and if we wanted to write a statement about this, you might be like, the power of working in notebooks, right, is that you can combine your text and your code and your output all in one place. So let's see how we can do that. If I wanted to actually make a statement in Markdown about this, and I'm not going to write a good statement, but I could say like, the slope is, then we're going to give it a little, instead of like R, you have like backticks and then R, for example, if you're working in R Markdown or in Quarto. Here, if we want to add the outputs of some JavaScript to a Markdown cell, we use this template literal, $, and then 2 curly braces. And then I'm going to give it whatever I want to from this piece of information. So I'm going to say crabs LM dot, and slope is actually a parameter that's stored as the output here. And you can see that now I have in text, I have this output. You probably want to not have this be a really outrageous number of significant figures, given that they're measured to like the closest 1/10 of a millimeter. So instead, I can say to fixed, notice the camel case there, and I'll just say, I actually want this to be 3 numeric digits. So you can customize what this looks like, but this is just an example to show that, like, yes, you can have like your Markdown or other elements also tied to the outputs of JavaScript like you would expect in other computational notebooks. Okay. So I think, thank you for, thanks for responding to that question about the new here. Okay. So now let's move on to our final visualization, and then we're just gonna learn how to share this. So for our final visualization, I'm gonna start by creating a scatter plot, and then I'm just gonna add some customization here. So here, for my final visualization, I'm also going to do this in plot. If you want to try to do this starting in a chart cell, that's totally fine. Actually, maybe we'll just do that. Why not? Let's just start in the chart cell. All right. So I'm going to go ahead and start by going to my add cell menu, choosing chart, and typing chart, and then selecting this first option. I'm again going to select crabs.js, that simplified version, using our kind of cleaned up variable names. And then I think, okay, I have different feelings about this. I still think it makes sense given how we modeled this to have latitude on the x-axis, even though I know like on a map, latitude is like a vertically structured thing, but I'm going to leave latitude on the x-axis as our independent variable. But I understand that there might be feelings about that. Okay, so I'm going to go ahead and select latitude on the x-axis. Again, if you have one variable selected, the first thing it's going to do is make a histogram of distributions. But then as soon as I select a second variable, in this case, a number, the size in millimeters, then I can see that it changes the chart type. Notice here that like sometimes the chart type is not what you want, but you can always override the automatic selection. So here I'm going to choose dots. So here I see, again, that increasing, again, showing as much of the data as possible while still being clear, showing that overall increasing linear trend in carapace size over latitudes. And I'm going to go ahead and I'll just eject to JavaScript at this point. So you could have written this. You could have started with a scatterplot snippet, totally fine. I'll convert this to JavaScript now, which makes a copy for me, and then I can go ahead and update this. And the biggest thing that I want to show here is that you can layer different compatible marks on top of one another, all within that marks section, which we haven't done before. And you can customize within each of them. So one thing that's really nice, among many things, is that Observable Plot actually has a linear regression mark in it, which actually like calculates the OLS so you can actually show the predicted trend line, and you can show the confidence interval around it. So here, instead of just having a dot plot, I'm going to have a comma. Notice that this is still within the brackets because this is still going to be within my marks that I'm adding, but it's outside of all of that plot dot code. So I'm not going to be changing anything about my scatter plot I have so far, but I'm going to add a new layer to actually show this trend line, which is plot linear regression y. So y is my dependent variable. So I'm using plot linear regression y. No, again, you can use the autocomplete. And then within linear regression y, I just again need to say like, what data are you pulling this from? Because you can within a single plot code, to some extent, not all things are compatible, but you can choose data from multiple sources. So you specify first which data you're going to use, here crabs.js, and then again, what your X and Y are. So here, X is going to be a latitude and Y is my size millimeters. And running that, I can see that now I have a nice trend line reflecting the model estimates that we found numerically above, now shown on my chart. And we also, there's also ways that you can add. We have a notebook on simple linear regression and observable so that you could add the equation right on your chart with the estimates. And you could customize this each layer however you wanted to. So for example, here, I could also add another one. One thing I find myself adding pretty frequently is plot frame, which adds a frame around the entire plot area. But you could also customize things not specific to an individual mark. And if you're doing that, then you can do that outside of those mark options. For example, I could customize the label in the chart cell, or I could, outside of marks, then outside of the square brackets for marks, I have a comma, or I could say outside of that, actually, I want the X label to be latitude. And then that will update. I could also update the Y label to carapace size in millimeters. And we could customize within these marks. So if I wanted my dots to have a fill color of steel blue, then I could update the fill color or the opacity. So we really have full control. Another thing you might want to change here is like the inset padding. You can change that either for like one margin or all the margins. You could update the image margins. You can change the tick mark intervals. So you really have full control over how you would want to customize this. But I think this pretty nicely shows like both with the raw data itself, which we love to see, but also in this expected linear trend that we had modeled using simple linear regression in the same place. The simple linear regression function also, you can also make predictions from it if you would want to. We show how to do that in our simpler linear regression notebook that we've created. But here we'll just say we just wanted to understand on average how much do we expect based on this data fiddler crab shell size to increase with each degree increase in latitude, which is what that value of 0.485 millimeters per degree is actually telling us, which is pretty cool. Okay, actually, let's get to like, who cares about this? Lots of people care about this. Like small increases in animal population sizes that are dictated by environmental conditions are really important. We're going to come back to the notebook in a second, but just to get to like, where does this fit? Like, what is the insight in this? This actually reflects like a rule. It's kind of a phenomenon more than I wouldn't say it's a rule. A phenomenon that's commonly observed in species globally, including like mammals, but also invertebrates and reptiles and birds like penguins, where
animals, even of the same species, tend to be larger in colder climates, and in colder water in this case. And this study, their conclusion was like, oh, this is actually interesting that even along like the east coast of the United States, um, they found that these fiddler crabs follow Bergman's rule pretty nicely. We saw this for the mean. They also looked at a couple of other measures that they used. And you can see that their conclusion is that on average, carapace width increased by about 0.5 millimeters for every degree of latitude increase, which is what we found from our linear regression. And one thing that they had hypothesized is that this might be due to how long of a time span there is between when the crab molts. So the molt frequency declines in colder water, so they're molting less. So there might be more growth in between those times of molting when they're not growing as much, which is one theory that they had in this paper. Bergman's rule is not like a thing you can apply to everything, but a lot of species seem to hold to this. But there have been more recent studies where it's like when you take 1,000 different species and look at them, it doesn't look like overall we can say this is like a totally generalizable phenomenon. But it does look like for these Manuka pugnecks, these marsh fiddler crabs, it does seem like it follows that. So pretty cool to see. Okay, so going back to our notebook, just to wrap up. So we see that these crabs seem to follow Bergman's rule. Like, oh my gosh, this is amazing. The world must know, but starting with my data science team, collaborators, and my manager. So how can we share this insight? How can we share this notebook and our interactive charts with other people? Well, sometimes when you make interactive things, sometimes you need to like publish them separately or host them on a server. But what's really nice is, again, since we're working in a web-based notebook in the language of the web, and since your notebook is already a web page, sharing it can be as easily as just sharing a link. So here, if I scroll up to the top, and you can do this too, one thing that you want to check usually is you want to check the permission settings. Here I can see that I'm the only person who can see my notebook right now. But if you go to share, you can update that so that like your team can be viewers and editors. And you can also make this like publicly available. So I'll make this viewable but unlisted so people won't like search for it and find it. You can also add a custom URL. It's maybe like my awesome fiddler crabs or something. Fiddler crabs. And then once you save those changes, then anybody you send that link to, they'll be able to open the notebook if they're viewers, interact with things independently. So like you playing with a slider in your notebook, they could be playing with it at different values. Those won't have crosstalk, so you can independently explore things. Or if they're added as editors, then we'll see in future sessions, you can actually co-edit in the same code, in the same place with your little avatars like you would in like Google Docs for typing. But this gives you a way where if you truly just like copy and paste that URL like you would any other site, share it with somebody, then you can send this along and other people could start learning alongside you, providing feedback, adding comments right in the notebook. So it makes it an easy way to share interactive, iterative data visualization and a place where you can have discussions right in Notebook about what you've created. All right. So that gets us to the end of session 1. Oh, this is if you're curious about like what we created, this is the publication in the original paper that was published about this data set following Bergman's rule. And yes, I absolutely do think that we would need to add a fiddler crab with giant claw if we really wanted to customize our chart. But we could see that like, yep, we are seeing the same patterns that they published in this paper in 2019. So that brings us to the end of today. Thank you so much. Session 2 is next Tuesday. We'll be doing more JavaScript, learning different methods for wrangling, modeling, visualization, interactivity, and collaboration. So make sure to come back next Tuesday at 9. We covered a lot today on the basics of observable, importing local files, doing some wrangling in JavaScript, checking out stuff in data table cell, observable plot through chart cell and from code snippets, importing a library for use, doing simple linear regression, and then visualizing it and then sharing. So like, congratulations everyone, because that is a lot in 2 hours. See you next week. Otherwise, have a wonderful day. Looking forward to seeing you back next time. Bye everybody. Thank you.